Hello everybody and welcome to Data Engineering Stuff. Today we're going to talk about the CAP theorem and how it is applied to data storage systems. So what is this CAP theorem all about? It's about these three letters, CAP, which stand for consistent, available, and partition tolerant. And the interesting thing is that there's a mathematical statement about this, and it said that you can't provide all three of these features when talking about distributed systems. So every distributed systems need to drop one of these properties. For example, RDBMS, like Postgres, they drop the partition tolerance. Cassandra stands for partition tolerant and available, but it's not that consistent. Apache HBase, on the other hand, is partition tolerant and consistent, but therefore not in every case, every data point is available. So I will make this clear in the following graphic. We have two data centers. We will reuse this graphic down here for every case. And in these data centers, there are two applications, application 1 and application A and B. They are locally in the data centers, and they have their instances of our distributed storage systems. Both applications write at their data center and read at their data center, but the data is distributed, so everything should be everywhere, or at least in every data center. So how does an RDBMS work? RDBMS has the notion of something like a master node. For example, this could be 2.1 here. So what happens if, I don't know, this here fails? It doesn't matter, because the application B can just interact with the master node. The writes from the master node are replicated to 101 and 102. And here the reads and writes work the same way. So it's not that problematic if something fails. So the interesting thing is that these systems that are consistent and available, they have all the data in every instance all the time. So they don't scale that well, it's no other topic, but the main problem is that they don't really care about partition tolerance. So what happens if I say this network is broken? This and this node, these instances, don't know if this master node over here still exists. So they have two options. The first is they say they are the master nodes themselves, or they could just say, no, we are not the master node. And then they have, again, two options, and that is we allow reads, knowing that we are not up to date, because here writes are allowed. And so we don't get this writes over there, so we're not up to date. Or we just say, no, nobody can read. And that would be not really that available. So in case of a consistent and available system, there's not a really good handling of partition tolerance. And that's basically the idea. In practice, it's often said that these CA systems don't exist, because you always have to take into account partition tolerance. And also these RDBMS systems have some measurements for that, and then they are not really that consistent or available. But we will see the actual meaning of the CAP theorem with the next two examples. So here we are in the world of consistent and partition tolerant. So how does that work? Apache HBase is such a system. So it has a region, something like a region. So all keys that fall into region A are replicated over there. So what happens in case of a node failure? No problem. If that node is away, you can still read and write here. So that's basically the idea. So it's could say it's available, But what is the important point is that if there's a network partition and you have here A and you have here A star, I would say, then you get into trouble, because do you allow a write here and here? And do you allow a read here? How does Apache HBase work? Apache HBase works in the way that it only allows reads and writes happening on this side. It doesn't allow anything on this side, because if it would allow anything to happen in data center 1, it wouldn't be strongly consistent, as updates from data center 2 could not have been replicated to data center 1, and that would go against the consistency in case of network partition. Let's see the counterpart to it, the Apache Cassandra. And Apache Cassandra would handle the same situation. So we have A and we have A star. And now the same question, do I allow reads and writes? Sorry for my drawing. And reads and writes. And Cassandra is really I would say brave when it comes to storing data. It says everything is allowed. So data is available in all data centers. Everything is there, and everyone can read and write. And if the partition of the network is removed, then it tries to resynchronize in the best way it can, because it's simply technically not 100% possible to do it the best way. But it does it in the best effort way, and that is why it's available and partition tolerant and eventually consistent. So now the big question is, what do we get from this? So I think the CAP theorem, you read it all the time, but I think it's a bit an overemphasized thing, because it's said that CA systems don't really exist in reality, because every system has somehow to cope with partition, with network partitions. And on the other side, yes, it just tells you that you can't be consistent and available in case of a network partition. So, okay, you have to choose between HBase and Cassandra, and you have to keep that in mind. Fair enough. That's the point, basically. But think about it is highly configuration dependent. For example, even in Cassandra, not all the data is there in every data center. Think about multiple partitionings in the network happening. For example, the internet breakdown, and you have 4 data centers, and perhaps your replication factor in Cassandra is too low, or it's not that well balanced, then there's not all the data available. Or how could you configure an RDBMS? You could say, okay, then just read stale data. It's okay for my use case. And then it's not that much of a problem that it's not that highly consistent. Also think about schemas, think about scalabilities. There are so much more properties that are really important. So the CAP theorem really tells you only one thing. If there's a network partition, you have to choose between availability or consistency. And there are systems that don't handle partitions really well at all and lose their properties at the end, like, for example, an RDBMS. So that's the idea. I hope I helped you with that. I hope you can have this on your list. I hope it's just one point on a really long list of how you choose the storage system you use. And yes, don't overemphasize it. It's just really one point, and it's not everything. The choosing of a system is all about. So thanks for watching, and see you next time. Thank you.